Hey everyone, welcome back to the Broke Coder. So, last time we left off at just making the board part of our tic-tac-toe game. So this is how our board looks so far, and in today's video we'll be continuing that and trying to implement just one player user logic into the game. So let's get started. So far what we've done is just this. We have a show board over here which will show the board as the name suggests. Let me just get rid of this, and yeah. So now what you need to do is, first of all, keep in mind that our main game will be running from here. So all of the function calls and all of the, at least the main part of the logic should be in this main function. So as not everything is just falling into pieces and everything's everywhere. So now, before we show the board, or let's just go do one thing. What we now need to do is make sure that we get what the user wants to be. Like, does he want to be an X or does he want to be an O? We don't know that yet. So we need to take that as an input here. So let's just not worry about that, and we can leave it as a to-do so that we can get back to it later on and do it. So let's just create it as make user input for X or O, and we'll get back to it later on. For now, let's just fix it at a, how do I put it, a fixed value, and let's just call it player key, and let's give our player an X. So what we'll do is our player will be X, of course, as it shows here, and as any game, what we need to do is we need to call a while loop. Now, this while loop can't just have a true inside of it, so that I have a bunch of statements, and then at some point I say, oh, if some condition satisfies, I would go ahead and break our few. That would not be wise, because in some edge cases, your program will still not break and you'll be running in an infinite loop. So an easy way of doing that would be, I should say, is make a function. Let's just call this function is empty for now. We haven't made this function yet. Let's go ahead up here and make that function before we go any further. So let's just call def is empty, and we can pass in the board for it, and we'll just say that for I in range 3, for j in range 3, if the board of I and j is equal to 0, just hold on, return true. Now this is extremely simple. We won't be using this in the final iteration of the project, but for now it'll do. So we have our empty function. Now what we need to do is we check each and every time, like as long as the board is empty, the show must go on. Well, not exactly an interesting show, but you get the point. So here we need to call again another function that you can call it as player turn. Now you might be wondering, I'm making more functions than I'm actually doing stuff, because this is actually helpful, because if you create functions for different things, if you modularize everything, if you keep things divided into different parts, then not everything just bees in one gigantic program, and to correct something you just have to read through entirely. So what this does is it just compartmentalizes everything so that it makes easier for you later on down the road. So let's just create this player turn, and this will take our player key in. And what the player turn now does is, our player turn is supposed to first check is our board empty or not, because if it's not empty, then it has no use giving the user. Why it's still inside even though we are getting here, we'll get to it in a bit. But let's just keep this condition here because it'll be good for us. Return, and hold on, what's wrong? Yeah. And then what we need to do is take the user's input as usual. So we'll say input. Now, exactly. You must, if you are actually following along while coding with this, you must be thinking, but we can't ask user to give an input because our user doesn't know. Honestly, we don't know. Like, how would we point to this location? or how would we point to this middle location, or how would we point to this bottom middle location? You can't write words in here, like you can't expect the user to write, okay, I want the corner tile rightmost. No, that's too much. So before we go ahead and actually take our user's input, what we need to do is make our tic-tac-toe board user input friendly. With that, what I did in my original program was to make sure that all of these 9 cells, I mean, there are 9 cells, so not an issue. This one would be called the first, this would be the second, this would be the third, the fourth, fifth, sixth, seventh, eighth, ninth. So instead of representing numbers here, I showed them as numbers, exactly 1, 2, 3, 4, 5, 6. So what we can do in showboard here instead is, let's just create a variable number equals 1. I mean, every time showboard is called, this number would be initialized to 1. And we'll say if this board I comma j is 0, and then instead of printing out that 0, all you need to do is just print out the number. But this would actually throw an error. Why? Because number here is an integer and this is a string, so you need to wrap this up inside string and you're good to go. So if you run showboard now, I don't think this will cause an issue. Okay, this might cause an issue. Yeah. So let's just not, hold on. Can't run this. There's nothing stopping me from running this. So let's just comment this part out for now. And if I run this now, I should be seeing, okay, I'm seeing 1, 1, 1 all over the place. Why? Because I initialized it to 1, but I never incremented it. So what you need to do is every time you print it, every time it's printed here or here, anywhere is fine as long as it's within the same for loop, the innermost for loop, you need to increment it by 1. So now if we run this, we should be seeing 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you have a way to tell the user, hey, I want so the user can actually point to a specific cell. I want to enter in cell number 6. I want to enter in cell number 7. I want to enter in cell number 1. That makes our jobs a whole lot easier. So the next thing that what we need to do is actually go back to our player turn, and we can say, now we can say enter cell number, like which cell number do you want to input in. And now what we need to do is kind of a little logic part. You need to think logically for this, is how would you map them? Like you know it's 1, how would you access this? If you are well versed in Python, you'd say it's a 2D array, so use a 2D array, and that's exactly what we'll be doing. For the rest of you, if you don't know what a 2D array is, you should like kind of look it up, or you can see in one of my previous Python tutorials. But for now, let's just say that, you know what, I'm too lazy. I'll just go and copy this dictionary from my actual code. And yeah, I have this over here. I'll explain in a bit what this dictionary is, because I don't want to type all of this again and again and again. So we have this dictionary over here now. So what this dictionary is doing is it's just mapping each number to their said coordinates. The number 1 is at 0, 0 because it's in the first one over here, 0, 0. Then wait, just this bit, 2 is 0, 1, 3 is 0, 2, so on and so forth. So the next one, the next thing that we need to do is we have our coordinates, and what we need to do is just a little check. But before our checking, what we need to actually implement is a little tuple unpacking, because we need to obtain these coordinates. Like say if a user picks 7, I need to get these two numbers, 2, 0. Why? Because I need to assign the user's X or O to that specific location. So let's get that, and that's just a one-liner. I could say X, Y equals not Deco of whatever the value user input is. So if the user inputs say 8, the 8's value of 2, 1 would be given back to these variables X and Y. That's called tuple unpacking, because these things are tuples and in brackets. Yeah, you get the point. So next one I need to do is say if the board of X, Y is actually empty, then what I need to do is assign them a value. Now remember, our board only has X and I mean, the board only has zeros at this point, and assigning them a value of X, or in this case, the value of the player key, because that's X, would be good, but it would cause a lot of problems down the line because this program is supposed to win against you, so it has to try and try. So if I actually put a string on there, I mean, in here, then it would be a bit difficult down the line to actually make it understand, like, okay, X is good for you, while O is not good for you, or O is bad for you, X is good for you. So let's just decide on a specific convention. Now what I did is say human would always be +1 for me, and the computer would always be -1 for me. These would be, that's it. All of the values in the board behind the scenes would always be plus and -1. Whereas to us, the magic happens inside the function showboard. Now, what we need to do is, if it's 0, I mean, if there is no value from either the computer or the board, or the computer or the human, then just show the number over there. Otherwise, let's just say elif, and I can say if board of I and J has a +1 over there, like if that's what the human entered, then I get to just copy this, paste it, and instead of showing number, I get to show the human, I mean the output of whatever they chose. For that, I need to pass in side showboard the player key as well. Yeah, I'll fix that in just a sec, and I need to get here as well, because the showboard function needs to have an access of what the player key can be. I cannot set the player key to be a fixed value, because that keeps changing in each game. In one game you may be X, in the other game you may want to be O, so that cannot be fixed. Don't try and fix that. And now what we need is another little dictionary I like to call play Deco. Now what this dictionary does is, it would actually be a mapping. Say +1 is player key, so that whatever +1, like every time you see +1, correspond it to whatever player key is. Now I can't do it the other way around, like whenever you see player key, put a +1, because that would be wrong and your code will crash really, really badly. And this would be the, yeah, just, we don't have a computer yet, so let's just leave it at that. And here, instead of having this, let's just wrap this up inside double quotes, and inside here what I can do is just say play deco of the player key. Wait, the player key, my bad, not the player key, I'm going crazy here. The board X, I mean the board I and the board J. So whatever the board I and board J value have over there, like say if they have a 0, then automatically this condition gets true and I get a number. If it's not, then I'd get a +1. So our one is pretty much done, and I can just go ahead and uncomment this. And I need to get this show board up from here down to here, so that I get to show it, and then I ask the player for a turn, and that's all we did. So let's go ahead and run this and see how it looks. Okay, looks good so far. It's showing 1 2 3 4 5 6 7 8 9. Let's say I enter 9, and wow, my 9 just went blank. So something's wrong. What's happening? I'm passing player key, you're getting the player key, I'm assigning the player key as X, and I'm passing that player key inside board, showboard. Showboard is not showing my X. Why are you not showing my X? Not that X, the other X. The Tic-Tac-Toe X, come on. Does say play deco board. And play deco of +1 should map to player's key. Now, why is it not mapping to the player key? It should map to player key. Hold on, we have an X here, we are passing that everywhere. Let me try changing this to X for now, just to check if it works, and I'll try solving it later on behind the scenes because that's where everything gets done, right? So if I again let's choose 5 this time, and whoa, things are going bad. Am I missing something? Oh, my bad. I did this mistake. So again, like I told that and I did this mistake. I don't know if anyone of you guys spotted it while watching this. I said not to assign it the player key, the string value, and yet I did. We should actually be assigning is the human value. That is what we decided to be globally for whatever the human chooses. So let me just, yeah, this X is a bad idea now. So let's just go back to player key and rerun this. Yeah. And now everything's gonna work great. Exactly. So I entered 5 and immediately 5 gets replaced by an X. I entered 3, it gets replaced by an X. 2, 1, I can just play around. I mean, at this point, it looks really bad, like because there's no space between them, all of them are coming joined up. We can all make that a lot more better later on. And well, that's it. That's pretty much it. Oh yeah, 4 is left and it just exits because there isn't any more any empty space, so it automatically exits from the loop. So in this video, that's what we did. Whoa. A little recap, we created a player turn which handles how a player interacts with the game. Right now it's just a one player game. We haven't done anything much fancy yet, and we surely made our show board a lot more showy. So with that, I'll end the video and I'll see you guys next time.